Welcome to HOYS, short for Hunting Outbursting Young Stars. In this project, we continuously observe clusters of young stars to discover stars that are experiencing an outburst or to find many other interesting objects. By doing that, we want to find out more about the processes that form stars and planets. In this project, we work in a large team with amateur astronomers around the world. It's a citizen science project, and you can join us if you like. In this short video, we want to give you a short overview about ways to contribute to the project. These are some of the regions that we are observing. We focus on nearby young clusters and star-forming regions that are visible from the Northern Hemisphere. Our clusters have been chosen so that they're interesting to keen astrophotographers. These are stunning nebula and beautiful groups of stars embedded in the nebula, as you can see in these pictures. It's entirely possible that you are already observing some of these regions, for example, to make fantastic images. And if that's the case, or if you want to start looking at these regions now, you can also produce scientifically valuable data at the same time. That's the basic idea for this project. If you want to contribute your own images for the HOYS project, you only need very modest equipment. A telescope with as little as 5 centimeters or 2-inch aperture can deliver really useful data for us. Obviously, the bigger the telescope, the better. You will also need a camera, but there are no specific requirements for that. Either CCDs or CMOS detectors or DSLR cameras can be used. Some fields are very crowded, and therefore we recommend that the pixel scale of your images should not be larger than 3 arcseconds. You do need a filter, but any optical filter from the ultraviolet to the I band is useful. This includes the tree color filters that you can find in many of the DSLR cameras. And besides the broadband filters, the usual ones, we are also interested in images taken through the filter center on the hydrogen alpha emission line, in case you have any one of those. And if any of the words that I've just used are confusing or incomprehensible, don't worry, we can explain and give instructions. The amount of observing or integration time is also very flexible. Even a few minutes of observing time every now and then are helpful. This allows participants to generate useful data for the project, even under challenging conditions or when there's not much time available. Of course, everyone is very welcome to spend as much observing time on the project as possible or as convenient. By spreading the observing between a large number of amateur and professional observatories around the world, we aim to observe our target star-forming regions at least once each day in all filters as a team, over many years to investigate the long-term behavior of the young stars. Spreading the observing over many people and countries also guards us against bad weather and other disruptions. The number of active participants in this project is constantly growing. We do now have over 80 participants from 13 different countries around the globe. All these people have sent in almost 50,000 individual images in which we have made more than 200 million brightness measurements of stars. This unique data set is stored in our publicly accessible database and can be used by everyone for their own research projects. Speaking of research, the HOYS data is used for a wide variety of research projects, mostly related to star and planet formation. For example, we study occultations of young stars by material in the immediate environment. This enables us to investigate the structure and properties of accretion disks very close to the star, at a much higher spatial resolution than can be achieved with direct imaging or interferometry. We can detect clumps associated with growing planets. We can also study the rotation of stars, as well as the properties and evolution of star spots on their surface. With our long-term coverage in several filters, we can follow the temperature and the size of these spots over time, as well as to trace their movement on the surface of the stars. Furthermore, we investigate the detailed behavior of stars undergoing brightness outbursts to better understand the growth of young stars. There are many possible further avenues how the unique HOYS dataset can be used. We want to encourage all our participants to explore the data collected in the project and to pursue their own research ideas. For HOYS participants, we have developed educational resources for all aspects of the project, including setting observations or how to get started with the analysis of the light curves. Those resources will enable you to undertake your own research projects. We work with amateur astronomers and teachers with or without their own telescopes, and please get in touch if you want to find more how to get started with your own work. Our team is continuously working on the scientific analysis of the HOYS data. All participants are encouraged to get involved in the data analysis and experience the entire process of scientific work, from collecting the data to the final publication. Everyone who wishes to get involved will, of course, get their efforts acknowledged by co-authorship on the publications. We are also publishing larger survey and overview papers about the project, and in those papers, every participant who contributed data will be added as a co-author if they so wish. The HOYS project is run by Dr. Dirk Fröberich from the University of Kent, Dr. Alex Scholz from the University of St. Andrews, and Dr. Justin Campbell-White from the University of Dundee. We are supported by a team of advisors that is composed of researchers, amateur astronomers, teachers, and public engagement staff. If you would like to get more information, please do not hesitate to get in touch. You can find us at hoys.space or follow us via our social media presence on Facebook, Twitter, and YouTube for regular updates, news, and discussions. Thank you very much.